Section 2.1 is titled The Change in Arithmetic and Geometric Sequences. So remember in Unit 1 we talked about the average rate of change. So we're going to start applying those ideas of how things change to sequences, which is what you guys just did in the Kahoot. So for a more formal definition, a sequence is a function from the whole numbers to the real numbers, meaning that we are only able to plug in whole numbers, 0, 1, 2, 3, 4, on and on. Not negative numbers, not fractions, not decimals, just these whole numbers. But we can get out negative numbers, decimals, fractions, things like that. We can get out any real number. As a result, when we graph sequences, we will have points, but we cannot connect them together, so they're what we called discrete or disconnected points. So it's discrete data for us. It will act exactly like a function technically acts, but it is a sequence because we do not connect the terms together. When we're starting to talk about sequences, there is some new terminology going on. When I'm talking about n, that is going to be the term number. That is like the input value. So it's like the x. The S of n, which stands for sequence in terms of n. Notice there's no parentheses, so it's not like S of x, it's S sub n, so it's a subscript. This is the actual term itself. It's like the output. So we have a term number, n, and we have an output, or the actual term, S sub n, which creates some sort of coordinate point, n, comma, S sub n. So it acts like, again, like a function, x's and y's, but we use a different format for them. So if we consider the sequence defined by S sub n equal to 4 times n minus 3, we're going to find S sub 1 and S sub 7. Notice, kind of like how function notation, the number would replace the x, these numbers replaced what in this situation? Well, okay, true, but specifically this said S sub n and now it says S sub 1. So what did 1 replace? N. So we're going to replace all of the n's with a 1. So if we're finding S sub 1, we are going to take all of the n's in the formula and replace it with a 1. So 4 times 1 is 4, and 4 minus 3 is 1. So we would say S sub 1 is 1. We'd have the coordinate 1, comma 1. It's literally just like a function, but we have different formats for how we write the equation. If we're doing S sub 7, what are we plugging into this sequence? 7. So we're going to do 4 times 7 minus 3. 4 times 7 is 28. 28 minus 3 is 25. So our coordinate point here would be 7, comma 25. The term number is 7 and the term is 25. It works just like an input and an output, like an x and a y. It's just a sequence. Does that make sense? Now there are two main types of sequences that we're going to be working on in this class, and they are called arithmetic and geometric sequences. Arithmetic sequences, I will change the S to an A because arithmetic starts with an A. And geometric sequences, I'm going to use blue, so G sub n. That's not super duper important that it has to be an A or has to be a G. Just generally speaking, it's easier to organize your brain if you call arithmetic A sub n's and geometric G sub n's. Arithmetic sequences have successive terms in an arithmetic sequence will have a common difference or a constant rate of change. That sounds familiar. Common difference or a constant rate of change. What kind of function had a constant rate of change? Linear. Arithmetic sequences will behave exactly like linear functions. The rate of change in the outputs is always going to stay the same. The formula for an arithmetic sequence is as follows, and it's really, guys, it's just point slope form, where we have the common difference D. That's what D stands for. That is the common difference. We called it a slope when it was a linear function, but in a sequence we call it the common difference. Then we have two more variables here. We have k and we have a sub k. K is some sort of input value that you get, and a sub k is the output of the k term. Because remember, these come in pairs, inputs and outputs. We have k as an input, a sub k as an output. Geometric sequences, on the other hand, are not like something we've studied yet in this class. They're going to be more like something you studied in previous class. The successive terms have what's called not a common difference, but a common ratio, which means they're going to have a constant proportional change from one dot to the next. Proportional means multiply. So these are going to be multiplying by some number to change from one to the next instead of adding or subtracting. Bless you. Which means that eventually these geometric sequences are going to behave like exponential functions. Exponential functions, if you've just that's a word I've learned at some point, but I forgot what it looks like. Exponential functions are the ones that do this. You know what I'm talking about? Those like curvy ones that go up. That's an exponential function as compared to a linear function that is constant the whole time. But the formula for a geometric sequence, which will be like the basic version of an exponential function, has three variables in it as well. You have the r, which is your common ratio. That common ratio, if you notice, is like inside some parentheses, right? It's like tucked in there. Make sure you know where it goes. That's called the common ratio. Then just like the formula for arithmetic sequences, you have k and g sub k, where k is some sort of input, and g sub k is the output that goes along with it. So for either of these two sequence formulas, what we're going to need to find to write them is how they are changing, either with a common difference or a common ratio, and at least one example, one pair of inputs and outputs, and we're going to be able to write the equation. But first things first, let's make sure we can recognize what type of sequence we have when we're given a list of numbers. So for each of the following below, we're going to determine if the sequence could be arithmetic or geometric. If it's one of those two, then we're going to identify either the common difference or the common ratio. Common difference is for arithmetic, common ratio is for geometric. So all we need to do, guys, is figure out how these numbers are changing. I recommend, just because it's kind of hard to do with the way they're printed on the paper, when you're handed a sequence of numbers, I want you to write it as if it's a table, which means I'm just going to take all those numbers and write them straight down, like a table of values. You have your first term, second term, third term, fourth term, fifth term. How do I change using multiplication or division? Well, no, let's do multiplication. No, what? Let's do addition and subtraction. How do you go from 7 to negative 2? Plus 5. How about from negative 2 to 3? How about from 3 to 8? And then, so we see we have what here? Is this a common difference or a common ratio? Common difference is with adding and subtracting. Very good. And since we have a common difference of 5, that means that this is arithmetic. It has a common difference, which makes it an arithmetic sequence. I'm going to jump on purpose over to number C. Again, I find it easier in these kinds of problems to answer the trend in the numbers if it's written from top to bottom. So I recommend you doing the same. If we have 16 and then negative 8, 4 and then negative 2 and 1, I always start. If you don't notice that, let's start with addition and subtraction just to see what happens. How do you go from 16 to negative 8 using addition or subtraction?
Plus 22. No, subtract 22, sorry.
24, I believe, no? And then I would have to add 12. And then I would have to subtract 6. And then I'd have to add 3. Clearly that's not the same number, yes? So maybe you did, what words was I'm trying to say here? Maybe you did notice right away. Jacory, what did you notice? It's divided by 2, but then they also change a sign. So how can I make that happen? Divided by negative 2. Now, because division symbol, have I ever ranted about the division symbol to you guys yet? This symbol right here is super annoying to me because it's actually a fraction sign. Did you know this? Yes. It says put a number here, put a number here. Oh, look, it's a fraction sign. So I prefer that instead of using the divide symbol like this, that you actually multiply by a fraction. So if we're trying to say divide by 2, instead I can call that doing what? Multiply by a half. So we're going to call this multiplying by negative 1/2. And then multiplying by negative 1/2. And then multiplying by negative 1/2. And multiplying by negative 1/2. Yes, that's dividing by 2 every time. And specifically to get the signs to change, you're going to divide by a negative, because then the signs will alternate. Since we are multiplying instead of adding and subtracting, do I have a common difference or a common ratio? Ratio. Common ratio is multiplication and division. Maybe write that down if you didn't know that. Common ratio is multiplication and division. Common difference is addition and subtraction, which means that this one is geometric. That is a geometric sequence. Now let's look at this one in the middle. Okay, we've started to kind of notice how to find these sequences, right? Let's write them down the way Miss Quigley says. So 1, and then negative 2, and then 3, and then negative 4, and then 5. And let's see how to change between these numbers. Okay, just addition or subtraction. How do we go from 1 to negative 2? Minus 3, and then negative 2 to 3. And then what next? Bless you. 7, minus 7. I went from 3 to negative 4. And then from negative 4 to 5? Plus 9. Yeah, clearly not the same number, so can this sequence be arithmetic? No. Don't like that. So we're like, well, that didn't work, so we try something else. Let's try multiplication and division. How do you go from 1 to negative 2? Times negative 2. How do you go from negative 2 to 3 using multiplication?
Wait, what was the question?
It's a fraction.
Agreed. Here's what I wrote down on my notes. I was like, well, it's not negative 2. And we know that it has to be the same the whole time, yes? And if it's not negative 2 for this multiplication every time, can this be geometric? No. So this sequence of numbers is neither arithmetic or geometric. It's a different type of sequence entirely. Main idea. If you're adding and subtracting, it has a common difference, it's arithmetic. If you're multiplying and dividing to change the number, it has a common ratio and it's geometric. Sound good? Now, on the back, the kinds of questions you're going to see, though, from this particular type of lesson isn't necessarily just like identifying the D or identifying the R. You're going to want to do something with that information. Something you may be asked to do is like example 3 that says, let a sub n be an arithmetic sequence with a sub 3 equal to 8 and a common difference of negative 3. And we're going to find an expression, equation, formula to represent a sub n. Now, I'm going to write this down again because it's on the front side of your paper and flipping back and forth is annoying. What we are filling out is the formula a sub n equal to d times n minus k plus a sub k. We need to fill out 3 parts of this equation to have written an expression for this function. We need to fill out the common difference, and we need to fill out the k and the a sub k. Those are the 3 things we need to replace in this formula to have written a formula for a sub n. Did they give us this information? They did. Which one's obvious? Which one is for sure that they gave to us? Yeah, common difference being negative 3, check. Now I'm telling you they also gave us the k and the a sub k. Where else could that come from? The example they gave, right? They said a sub 3 is equal to 8. My friends, that is the coordinate point 3, 8, which is k and a sub k. So k is 3 and a sub k is 8, which means that we can write an expression for a sub n by writing a sub n is equal to the common difference, negative 3, multiplied by n minus 3 plus 8. Again, I substituted k and a sub k and the common difference into the formula, right where they belong. K is an input, A sub k is an output. I can ask a very similar question, maybe if it's geometric. Again, because the formula is on the front side of your page, we're just going to write it down here so we know what we're filling out. This is g sub n equal to g sub k times r to the n minus k. Only 3 things you have to fill out here. Those 3 things are, and then k and g sub k. Those are the 3 things we're going to need to fill out. Do we have those 3 things? We do. It says let g of n be a geometric sequence with g sub 3 equal to 7 and r equal to 2. Find an expression for g sub n. G of sub 3 of 7 means that I have the coordinate point 3, 7. We plug in that coordinate point, we plug in the common ratio. Our geometric sequence can be written as 7 times 2 to the n minus 3. Say again? The subscript of the g is 3, so the input value is 3. We did. The subscript of this is 3, so the k is 3.
It goes from like greatest, least to greatest.
In the coordinate point? No, it goes from the subscript is always the input value. Whatever that is equal to is the output value. So if I wrote down, this is a great moment. If I wrote down s of 8 equal to 2, what is the input value?
Maybe the 2.
What's the subscript? 8. What's the output? 2. Whatever the subscript is your x coordinate. Whatever it's equal to is your y coordinate. Can we try another one? Just good practice. If this said s sub 10 equal to 27, what's the input value? And what's the output value? 27. Okay, I'm using input value, output value. This is technically term and term number. Okay, what if we take it a step back? We go a little bit harder here.
Why does everything have graphs?
Why does everything have graphs? Don't worry, it's not that bad. Example 5 said, let a sub n be an arithmetic sequence with a sub 2 equal to 7 and a sub 6 equal to 9. Find an expression for a sub n and use the expression to find a sub 24. Okay. We said earlier that the things we needed to write an arithmetic sequence is the common difference and at least one coordinate point. Are we given the common difference? No. Oh no. We're going to have to find the common difference. Here's what I want you to think about when they give you 2 coordinate points and no common difference. It's kind of like when I give you 2 points and ask you for the slope. You can find it. What we're going to do is we're going to let this be 2, 7, and we're going to let this be 6, 9. So because I like to keep my numbers positive and I know that I'm going to be subtracting the input values on the inside, I want my larger input value to be n, and I want my smaller input value to be k. So we're going to switch the labeling on here, and this is n, and this is k. This is what I had before, is it not? So I just plugged it in wrong. Okay, I'm here now. I've got it. I'm going to stop looking at my notes and just do the problem like I know how to do it. If we label it like this, and again, I like my larger number to be the n so that I'm not subtracting and immediately making a negative number. And we fill this in. A sub n, which should go first, is 9. We don't know the common difference, so we leave that as a D. We open parentheses, the n is 6, the k is 2, and the a sub k is 7. That is mathematician's choice. The way that I had written it the first time before we paused and came back would have been okay. I just don't personally like doing that as much because you immediately create a negative number. And I don't love that for me. How many variables are left in this formula that I just wrote? Only one. And what is it that I'm finding when I solve for this formula? The common difference, that's what we were missing, yes? So let's solve. 6 minus 2 is 4. So this is 4d plus 7 equal to 9. So we subtract 7 from both sides. It gives me 2 equal to 4 times d. Divide by 4. What's 2 divided by 4?
What did you just say?
2 divided by 4. A half, yes. 4 divided by 2 would be 2, so 2 divided by 4 is 1/2. And voila, we have our common difference, which isn't what this question was asking for. It's just a step we needed to get there. But now that we have the common difference of 1/2, we can go back to the regular formula and plug it in. We would say that a sub n is equal to that common difference of 1/2 multiplied by n minus 2 plus 7. So we found the common difference by plugging things in, used the common difference and one of the formulas, the k's, to plug it back into the formula, and now we have an expression. But once we have an expression, we can find a sub 24 super easily. A sub 24 is what we're going to get when we do 1/2 times 24 minus 2 plus 7. And that is either a calculator question, or if you're on a non-calculator section of the test, a brain question. Let's do it with our brain. What is 24 minus 2? 22. PEMDAS is telling me to start from the parentheses, so I do. Then it tells me to do multiplication and division, which means I'm going to do half of 22. 11. And 11 plus 7? 18. We are essentially writing a sequence equation using the information we are given, and then using that information, or that sequence equation, to predict the future. Let's try another one so that I don't confuse you at the jump, right? This next one also wants us to do the same exact thing, except this time it is a geometric sequence. So we're going to label our coordinate points, making sure that the larger equation is the n. The larger letters are the n. Yes. So this is going to be k and g sub k. This is going to be n and g sub n. Technically, it doesn't matter which one you label which. It's just easier, especially with geometric, if the larger one is n. So if we fill in the geometric formula, which I'm reading from example 2, we wrote it down up there with the little blue r. G sub n I labeled to be 96. G sub k I labeled to be 12. The r, we don't know. We're going to find that out. Raised to the 4 minus 1 power. Okay, let's start figuring this out. Let's do two things at once. We're going to divide both sides by 12 so that the 12 in front of the r goes away. So what is 96 divided by 12?
8. Wait, yeah, 8.
8. Very good. So we have 8 equal to r to the 4 minus 1, which is third power. How do you get that r by itself now? Oh, but not a square root because it's a third power. What's that called? To get rid of square, you square root. What do you do to get rid of a cube? Cube root. Yeah, so we're going to have to do the cube root of 8. Bless you. By the end of this class, you will know your power families enough to know what the cube root of 8 is, like it's the back of your hand. I know right now we don't know our power families very much, but let me help you out. What's 2 times 2?
4
Times 2?
6.
What? 8. So what's the cube root of 8?
8.
Let me start that again. What's 2 times 2?
2.
2 times 2 is 4, times 2 is 8. So what's the cube root of 8?
3.
2. Ay, ay, ay.
Was it 2 or 3?
It's 2. Because 2 times 2 times 2 is 8. So the cube root of 8 is 2.
Oh, okay. I just didn't know.
We're going to get our power families. Don't you worry. I know what I've planned in the spring. Okay, so now that we have the r, we go back to the regular formula and we fill it in. We leave the n's there. This is g sub n equal to 12 times 2 raised to the 4. Yes? No, n minus 1, not 4. To the n minus 1 power. There's our formula. Because we want to leave the n's in the formula. That's what the formula should have in it. We're only switching out the k's, g sub k's, and r's. We leave the n and the g sub n. Now this question wanted us also to find g of 6. G sub 6 tells me to plug 6 into the formula. This is 12 times 2 to the 6 minus 1. 6 minus 1. 5. So we're doing 12 times 2 to the 5th power. Here we go again. What's 2 times 2?
4.
Times 2.
8.
Times 2.
64.
16 times 2.
8 times 2.
I thought you said 8 times 8.
No. So 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is, what was that again?
Oh,
32. So now I know, again, I'm making you do all this arithmetic in our head. Now we need to do 12 times 32 in our head.
Oh, Lord. 32. 127.
Bigger.
142.
Okay, it is in the 300s actually. So here's when we go to this thing. Yes? I almost put a plus sign. Do we remember how to do?
4, 6, 64.
So 2 times 2 is 4. 2 times 3 is 6. Skip a space. 1 times 2 is 2. 1 times 3 is 3.
Good job.
If this is the calculator section of our test, we'd be so cooked. Wait, I said the backwards. We'd be cooking. I said it backwards, right? I'm hip. I'm going to say it all the time now that I got it wrong. I'm gonna specifically do it wrong. Actually, I really was trying to do it right. That's embarrassing. It's okay. If we look at examples 6 and 7, yes, it has a graph. Because remember, sequences can be put on a graph. They're just not going to connect the dots. So don't go through this and connect the dots. Sequences are not connected. Several terms of the arithmetic sequence a sub n are shown. Find an expression for a sub n and use the expression to find a sub 17. Okay, here's what I notice if I look here. What's the input value for this dot?
8.
Input value?
0.
0. What's the output value? 8. So we have a coordinate 0, 8. How about the next dot? What's that coordinate?
1 and 6.
1, 6. What about the next one?
2 and
4.
And then?
3 and 2.
Okay, do we see a pattern here?
Maybe.
What's the pattern happening with the numbers in the sequence?
Linear.
It's linear, which means that it starts with an A.
And
I don't even know.
Arithmetic. It looks like the word arithmetic, yes, but it's pronounced arithmetic. This is an arithmetic sequence. Oh, snap. And in fact, just from looking at that pattern, what is the common difference for this arithmetic sequence?
Are we looking for the x's or
The y's. So it's 2, but not really, because it's not going up by 2.
It's negative?
It's negative 2 because we're subtracting 2 each time. That's the common difference. That's how it's changing each time. We didn't have to go through the whole mess of using the input values like I made you do on the other 2 problems. You can see how they change each time. Skip that step, find the pattern. The pattern here is -2, which means the formula here is a sub n equal to the common difference, which is -2, times n minus k. Now, this is mathematician's choice, and I really will let y'all choose whichever one you want. We need at least one example coordinate point. Which of those would y'all like to use? 2, 4? Great. So this is going to be n, nope. This is going to be k and a sub k. You could have picked any of them. They all work. So that means that we're going to have n minus 2 plus 4. You could have put n minus 0 plus 8, n minus 1 plus 6, n minus 2 plus 4, n minus 3 plus 2, n minus 4 plus 0. Any of those coordinate pairs will work. That is an appropriate expression for a sub n. Any of them will work. But if we go on, it says to find a sub 17, which means all we need to do is plug 17 into that formula and calculate without a calculator. Ooh. 17 minus 2, we start on the inside with PEMDAS. So 15 times negative 2, negative 30, and then negative 30 plus 4, negative 26. We would have gotten the same answer if we used any of those coordinate points. These?
Yeah.
The formula, I'm gonna scroll really fast. The formula on the front page, which we rewrote here, that's what I'm filling in each time.
Oh.
Okay.
It is on the front page, so you can leave that like face up whenever you're doing your work. Okay, let's do this last one. It says several terms of the geometric sequence G sub n are shown below. Oh, look, we have a graph again. Let's see if we can just rely on the outputs of the graph to determine the common ratio. What's the first coordinate point there?
1 and 4.
So that one is there, but there's one before that.
Oh, 0 and 8.
0, 8. Okay, and then what's the next one?
1 and 4.
Yes.
Oh,
2 and 2.
2 and 2.
And then
3 and 1.
3 and 1, and then
1 and 1.
4 and 1.
5 and 1.
Hello.
Wait, which one do you want?
it's 4 and
4 and a half.
a half. Nice. It's getting really small and my handwriting is not that good. Do you guys already see the pattern though?
Not really.
It's going like that, so it's
It true. Our outputs go from 8 to 4 to 2
Oh, divided by
to
2.
1. Divided by 2, but we're going to call it,
multiplied by half.
Net.
Okay,
we're going to call it that the common ratio is a half. 8 times a half is 4, times a half is 2, times a half is 1, times a half is a half. The next one would be a quarter. Okay, now again, mathematician's choice. I don't care which one you use. Which coordinate point would you like to use for k and a sub k?
2,
the
2.
easiest one.
Sure. I personally think anything with 0 on it is easy, but like you guys picked it already. Okay, great. So we have g sub n equal to 2 times the 1/2 raised to the n minus 2 power. And if the question that you're about to ask is where is she getting this formula from, remember it's the front of this page, but I wrote it up here at the top. It's a good, legitimate question. Okay, great. That's my formula right there. Hooray. Let's use it to find g sub 10. This is 2 times 1/2 to the 10 minus 2 power. What's 10 minus 2? 8. So we're doing 2 times 1/2 to the 8 power.
No, miss.
Yeah, we're doing it.
Okay.
How would you do that?
Probably 40.
I think on
Exponents for fractions can go to the top and the bottom separately. So what is 1 times 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 1?
8.
Nice. What? It should be 1. Let's do that for the denominator. I'll go slower this time. What's 2 times 2?
4.
Times 2.
8.
Times 2.
6. Wait.
16.
Yeah.
Times 2.
32.
Times 2.
64.
Times 2.
128.
128.
Times 2.
Oh. 2. 3.
256.
256.
Where the fuck did I get 3 from?
Whew. Have y'all ever played that 2048 game on the phone? You know what I'm talking
Y'all
about?
did 2, 4, 8. Y'all
With the
got
box?
grab blocks and it add multiply.
That's an exponential power 2, so it's exactly what you're doing here. Because, you know, the blocks are always 2, 4, 8, 16, 32, 64. These numbers. You were learning math. So this, if we're keeping going, yes, 2 times 1 over 256 is 2 over 256. And then since both the top and bottom are even, we can divide them by 2, which brings us back down to 1 over 128.
That's a big number.
Well, it's actually a very small number.